vacuum to the speed of light in any other medium is also known as refractive index. So C by V is the relative refractive index. If you know the speed of light in any other medium, we can calculate the refractive index of that medium. Suppose we know the refractive index of a medium, we can calculate the speed of light in that medium. For example, the refractive index of glass 1.5 or the refractive index of benzene 1.5. So you can easily say the answer what is the speed of light in benzene. How much it is? No, 3 into 10 to the power of 8 by 1.5. So n is equal to C by V, V is equal to C by N. 3 into 10 to the power of 8 by 1.5. So half of 3 is nothing but half of 3 is 2 times 1.5 goes how many times in 3? 2 times. So the speed of light is equal to 2 into 10 to the power of. So refractive index is one of the important factors. How extent that light deviated in that medium. What angle, deviation, measure of deviation. So refractive index is one of the important one of the important physical quantity. So to express the different mediums and their properties. So experimentally you can calculate, you can determine the refractive index. So that experiment is nothing but measurement of refractive index of a prism. You know this is a prism. So it has how many surfaces? Prism is a transparent material bounded with the 3 plane surfaces. So these two are the angle between the two surfaces is known as angle of prism. This is also angle of prism. Angle of prism. This one. This is a equilateral prism. All angles are equal. So this also light gets refraction. How the light gets refraction? So I developed a project like this. Simple project. Last year in our science exhibition, before the science exhibition, I developed this project. See here, this is the incident ray. This is a refracted ray. Incident ray, they are different angles. This is normal. A line drawn with 90 degrees is the normal. So these are the different rays, 30 degrees, 40 degrees, 50 degrees. So on one of the line, so I put 2 pins here. Yes, I inserted 2 pins here. These are the screws. Otherwise pins may be so fall easily. So I chose these screws. So the title. This is nothing but incident ray. The incident ray is taking the surface, refractive surface here. It passes through the prism and comes out. This is our emergent ray. This is emergent ray. This is the incident ray. So in the prism that is called refracted ray. The incident ray is making an angle with the normal angle of incidence. The refracted ray. How it can be? So these 2 point pins are pushed, pointed here. So keep the prism like this. So these are the objects. These 2 pins are the objects. You can see the image in this direction. Is anybody? One of you come to this side. You see the images. The images of these 2 in this direction. Not there. Turn your head such a way. Where see the side? Through the pins only you can see. Other side you have seen pins. So you feel that there are 2 pins here. So these 2 pins are image of these 2 pins. The same direction you so take 2 points here. So join those 2 points, you get a line. That is the emergent ray. So remove the prism here and you extend the emergent ray, the backward direction. At the same time, you also extend the incident ray so in the forward direction. In the absence of the prism, the light ray might be passed like this only. So actually, in the absence of the prism, the light ray may not deviate like this. So it goes in this direction only. But because of the prism, the ray is deviated. So almost this direction, it is deviated like this. So this angle is known as angle of deviation. This is known as a deviation. So by the trigonometry, geometry, you can derive the equation n is equal to sine a plus dm by 2 by sine a by 2. A is the angle of prism, D is the angle of minimum deviation. So by experimentally, by using a protractor here, we can measure the angle. Angle of prism also we can. So directly measure this. Of course, equal prism. So you treat it as 60. But how we can treat it as 60? So there is another experiment. You fix 2 pins here and again 2 pins here. These images you can see in this direction and in this direction. You join these two, they may intersect somewhere. There the angle is equal to 120. So here the angle is equal to 120. So there is a way of measuring the angle of prism. So no need to measure the angle of prism. Alright. So just you determine the refractive index of the glass material. This is glass material. What is the refractive index of this glass? Sin A 60 plus D, suppose it will be 40. 60 plus 40 by 2 by sin 60 by 2. Sin 100 by 2 by 60 by 2. Sin 100 by 2, sin 50 by sin 30. Sin 50 value you say in the you see in the logarithm table, logarithm book, you may have something. So really you may get some 1.45, 1.49 something. So this is the easiest way to determine the refractive index of the prism. But you are doing this, are you interested to do this? So this is the way. This is the actual classes and so knowing about the subject. This chapter, least distance of distinct vision. So you don't know this, even though 99% people can't know this. We can't read, we can't see the objects clearly. So very near to the eye. The object must be at a minimum distance. If an object is at a distance of 25 centimeters from the eye, then only we can read it or we can see it. That is the minimum distance. So the distance, the minimum distance between eye and the object, which we can see it or which can read it, is known as least distance of distinct vision. In case of healthy person, its value is 25 centimeters. However, so its value changes from person to person. In case of old people, its value is 100 centimeters, 1 meter. Children, 6 centimeters to 7 centimeters. The child can read by keeping an object at a distance of 6 to 7 centimeters, but whereas we can't read. So this is one of the important word we use in this chapter. Same time, angle of vision is also very important. Vision angle. So to see the object top to bottom, head to tail, suppose a clear object to see, so some angle is important. The angle between the upward rays and downward rays. That is 60 degrees by experimental, we came to know that 60 degrees is the angle of vision and 25 centimeters is the least distance of distinct vision. So these are the 2 important points. So object is at infinity means, can you say what is the object distance? Object at infinity, we are seeing the Himalayas or we are seeing the clouds. Tell me what is the object distance? Infinity. More than 4f is nothing but infinity. So infinity. So object at infinity means u is equal to why you are saying minus? So why minus you are using here? So it is a sign convention. Distance is measured always from the optical center or from the pole. Distance measured along the direction of the incident ray taken as but opposite to the direction of the incident ray taken as at the same time we need to measure the heights of the objects and images. So the heights of the objects or images in the vertical opposite direction positive. Y-axis is positive. There y-axis is positive. If you measure the downward direction, so y-axis values are negative there. Left side x-axis values are negative. Right side x-axis same. It is nothing but Cartesian coordinates. Yes, it is a Cartesian algebra. So already you know it. No need to say again and again. So these are the rules for sign convention. So coming to the rules for drawing the ray diagram. So what is the first rule? Minimum 2 rules we need to draw any diagram. The ray which is passing parallel to the principal axis after reflection or diffraction, it goes to the focus. The virtual ray may focus or the real ray may focus. It depends upon the nature of the mirror. So the counter of this, the same rule we can explain in the reverse manner. Ray which passes through the focus. After reflection, it goes past to the focus and parallel. One more rule: a ray which passes through the center of curvature. No, in the case of lenses, center of curvature. Optical center. Is it optical center? Yes. So it doesn't deviate. Suppose a ray incident normally on a plane mirror. So can you say the reflected ray goes in which direction? A ray falls normally. This is a normal reflection. Angle of incidence is equal to 0. Normal itself is the incident ray. There is no angle between them. Then the angle between them is equal to 0. The ray incident on the surface again it comes back in the same direction along the same path of the incident ray. So you know the laws of reflection. Angle I is equal to if angle I is equal to 0, angle R is also 0. So normal reflection angle I and angle of 0. The angle of incidence is equal to 45. What angle of reflection? 45. So this is the first law. Angle of incidence and angle. What is the reflection? When a ray of light incident on the smooth surface, a part of light bounces back into the same plane. That is known as reflection. Suppose a ball is thrown towards a wall with some angle, so the ball goes in the other direction. It is exact concept of reflection. Ball is reflected. Some amateurs, so they used to play and learn the game by throwing a ball towards a wall. So every time they throw the ball towards the wall, again he catches. Angle of reflection, angle of incidence. Angle of incidence, reflection, both are same. Suppose if he throw the ball towards a wall with some angle, So can he caught the ball? No, the person who is there, he can caught. So both are not same here. So just how a ball hits a wall, it comes back, it is nothing but reflection. In our light, there are 6 important phenomena: reflection, refraction, diffraction, interference, and scattering, dispersion. Bending of light when passes from one medium to the other medium. Changing of light when it passes from one medium to the other medium. That is known as refraction. Bending, the direction of light is changing. When the light ray is changing from the rarer medium to the denser medium, it bends towards the normal or away from the normal, towards the normal. Same when the light ray is traveling from the denser to rarer. So here angle of incidence and angle of refraction are same? Not same. But there is a relation between the angle I and angle R. What is the relation? Who developed the relation? What is the tool? What is the tool? Snell's law. Snell was a scientist. He established a relation between the angle of incidence and refraction. Sin A by sin R. The ratio of the sin A by sin R is always constant. But sin A is not equal to sin R. I increases, R decreases. But the ratio is always constant. So that constant is nothing but refractive index. So refractive indexes are 2 types. Relative refractive index, absolute. It is absolute. By measuring angles is absolute. By measuring the velocities is the relative. So let the velocity of light in the rarer medium is C and the denser medium is B. Then refractive index is equal to C by D. Type of class. This is our laboratory. This is the scientific material. So there are some books also here. Today I want to explain a topic based on the project, a real project. It is not a duplicate, not a showing purpose. So it is in your chapter, I think human eye. This is one of the chapter to you. Human eye in the colorful world. So already the chapter is completed. All you know about the human eye. It is an important sense organ in the human body. It enables us to see the wonderful world around us, colorful world. Eye is mostly spherical in shape. The front part of the eye is mostly sharp, covered with transparent protective membrane. 70% of light refracts through this is known as cornea. Behind that there is a chamber filled with liquid. The name of the liquid is called aqueous humor. Kind of water protects the eye from the external troubles like temperature and some humidity like that. There is protection. And behind this there is a colored part in form of circles. Colored part in the eye is called iris. In the center there is a black hole. Today it is not a lens, it is a black pot. So most of the light passes through it. Only this black in color reason is, so light once entered into the eye, so the light again not come back. That's why it appears to be, what you know about the black body? A body which absorbs more light and doesn't emit light is known as black body. So the pupil is also black in color because of, so once light passes through it, actually light is passing through it, but it cannot reflect, so it cannot reflect. And then there is a crystal lens made up of some jelly-like material, that is known as a lens. So the lens is under control of the ligaments, suspensory ligaments, followed by the muscles which are called ciliary muscles. So the size of the lens, size of the eye lens is a convex in shape. So it is controlled by the ciliary muscles. The function of the ciliary muscles depends upon the age of the person. So by aging, the expansion and contraction of the muscles may some change. So that leads to the defect of the eye. Later you may study those defects: myopia, hypermetropia, presbyopia, and one more, astigmatism, cataract. There are 5 defects of eye. This lens, the focal length of the lens automatically changes. That is the gift to us given by God. Whereas our ordinary lens, a lens like this focal is fixed because of it is a man-made lens. It is not the man-made lens. So by birth the lens made by the muscles. Anyhow, the focal length of the lens in such a way that we can see the near objects and we can see the far objects very clearly, very distinctly. So that capability of the eye seeing the near objects simultaneously, far objects, known as accommodation of the eye. Accommodation of the eye. So the focal length, minimum focal length is equal to 2 point, what is the value? What is minimum focal length of the lens? When the muscles are contracted. So less than that, the muscles cannot contract. So the minimum, the focal length it maintains is 2.27. So expansion of ciliary muscles increase the focal length, means decrease the power of the lens. Increase the focal length means decreases the power. You know the relation between the power and the focal length. Focal length is the reciprocal of the power. Power is equal to reciprocal of the focal length. Power is equal to 1 by f in meters. In centimeters it is 100 by f. So this one. And the rays which are passing through the lens, at last they fall on the retina, which is the screen. Yes, in between the retina and the lens there is a space. That space also filled with another kind of liquid. That is the vitreous humor. It is a liquid actually. In Telugu, it is known as kanneeru. So when some problems arises in eye, so what comes out from the eyes? So in such a way, the eye is being protected by the water chambers, just like a shock absorbers. So to a vehicle, the shock absorbs, how the shock absorbers gives not to create any problem. So to save the vehicle always, shock absorbers are very important. So retina is also that is memory. It has some important cells which are called receptors. These receptors are 2 types. and they are called rods and cones. Conical in shape, the cells are conical in shape. Cone, you know, cone. Conical in shape are cones. Rods, almost these are nearly 1 million receptors are in our human. So these are responsible for the absorption of light. They are responsible. They react to the light. So receptors means they receive. So here the light is so converted into visual. These are converted into the retina. These cells converts optical signals. What the light coming from the object and after passing through eye and when fall on the retina's job is it is a transducer. Transducer means a device which converts one form of energy into another form of energy. So here the retina converts optical energy, optical signals into electrical signals, just like electrical signals. So these electrical signals are carried out by the optical nerves to the brain. How many nerves are there? Nearly 2.3 billion nerves are there. So the electrical information is carried out to the brain through the nerves. So the brain intersects, so it converts into the images. So we are seeing the images in front of us in our brain only. So most of the people feel that it is seeing out with our eye only. Eye job is very limited. So almost the process is made by the brain only. In the brain only we are seeing the images of the objects. So this is about the human eye. So